the EMF and internal resistance practice question part 1. Okay, this is the question 9. Okay, 9. A circuit is connected as shown below. The battery has an EMF of 10 volts and an unknown internal resistance lowercase r. A voltmeter V1 is connected across the battery and another voltmeter V2 is connected across the switch S. The connecting wires have negligible internal resistance. Okay, you are given the following circuit. Now, switch S is initially open. 9.1, write down the reading on voltmeter V2. Okay, 1 mark. Voltmeter V2 is connected across the switch S. Okay, switch S is initially open, so the circuit is not complete. Okay, you have the current from the battery will come at this node. The current is going to divide and then join at this node and then carry on. Now the switch is initially open, so the circuit is not complete, so the current is not going to flow in the circuit because the switch is initially open. So write down the reading on voltmeter V2, 1 mark. When you follow the connecting wires, you are going to see that voltmeter V2 is actually connected across the battery. Let me show you. You can see. Okay, when you follow the connecting wires, you are going to see that voltmeter V2 is actually connected across the battery the same way voltmeter V1 is connected. So voltmeter V2 is going to read the same voltage as voltmeter V1 when switch S is open. So voltmeter V2 is going to read 10 volts when no current is flowing in the circuit. So voltmeter V2 and voltmeter V1 will read the EMF when switch S is open, when you have an open circuit. So V2 will read 10 volts. Now question 9.2. Switch S is now closed. Okay, switch S is now closed. The reading on voltmeter V1 is 8 volts. Okay, 9.2. What is the reading on voltmeter V2? Okay, so you have switch S is now closed. Okay, so switch S is now closed. Now voltmeter V2 is connected across the switch. Okay, across switch S. So V2, when you close the switch, V2 is going to read 0. Okay, because we don't connect a voltmeter across a switch. This is the same way as if you are connecting a voltmeter across a portion of a connecting wire. This is not the right way to connect a voltmeter. A voltmeter is always connected across a battery or a resistor or a bulb or anything as such. Okay, so V2 is going to read 0. Now question 9.3. Calculate the total external resistance of the circuit. 3 marks. Okay, 9.3. We have, can you see we have a parallel connection? Okay, we have a parallel combination in series with this. Okay, remember switch S is closed, so you have a complete circuit. Okay, so let's find the parallel combination first. Okay, RP is equal to, you can do this 1 over 5 plus 1 over 10. You close your bracket, you raise everything to the power of -1. So no need for you to flip. So this is equal to, you can use your calculator if you want. Okay. 1 over 5 plus 1 over 10. You raise everything to the power of -1. Okay, you have 10 over 3. 10 over 3 ohms, right? So this is for the parallel combination. Now to find the external resistance, okay, the external resistance, you have this combination is in series with this. So you are going to have 10 over 3 plus 2. This is equal to, you are going to have 16 over 3 ohms. In decimal, you are going to have 5.33 ohms. You have the total external resistance of the circuit. Now question 9.4. 9.4, calculate the internal resistance, okay, lowercase r of the battery 5 max. Since you have the EMF, you can try to use this formula, okay, because you have the EMF, okay, and you have the external resistance, okay. Now the question is to find the internal resistance, okay, lowercase r. You don't have the current, okay, you don't have the current. So let's find the current. We can find the current using the formula for external voltage, okay, because we are given the external voltage. When switch S is closed, now you have the external voltage, okay. When switch S is closed, now you have the external voltage. So the external voltage, okay, the voltage supplied to the external circuit is equal to 8 volts, okay. This is the voltage or the potential difference supplied to the external circuit, okay. This is equal to, you have the current times the external resistance, okay. So voltage is always equal to the current times resistance, okay. For external voltage, you have current times external resistance, okay. So we can use this to find the current. 8 volts is equal to the current times the external resistance, okay. This, you can use this in decimal, or you can use the fraction. The current is equal to, you are going to divide by 16 over 3 on both sides, okay. You have 8 over 16 over 3. This is equal to, you are going to have 8 over 16 over 3, okay. You have 1.5, okay. This is 1.5 amperes, the current, okay. Now you have the current, okay. you have the current, you have the EMF, okay, you have the external resistance, okay. Now you can find the internal resistance. So let's plug everything into the formula. Okay, you have 10 volts is equal to 1.5 in bracket 16/3 plus lowercase r, you close your bracket. Now from this you have 10 volts is equal to 1.5 times 16/3, you're going to have 8. 1.5 times lowercase r, you're going to have 1.5 times lowercase r, okay? So from this, when you take 8 to the left, you have 10 minus 8, which is 2. This is equal to 1.5 times lowercase r. Now you can find the internal resistance. Okay, the internal resistance is equal to, you are going to divide by 1.5 on both sides. Okay, you have 2 over 1.5. So this is equal to 1.33 ohms. You can also solve this question using the internal voltage. Okay, you know the EMF is equal to external voltage plus internal voltage. Okay, from this, the internal voltage is equal to, you are going to take this to the left. Now you have EMF minus external voltage. Okay, EMF is equal to 10 volts minus external voltage, which is equal to 8 volts. So this is equal to 2. Okay, so this is the internal voltage. You can use the internal voltage to find the internal resistance, because you know the internal voltage is equal to current times internal resistance. So you have the internal voltage, which is equal to current, okay, 1.5 times lowercase r. Now the lowercase r is equal to, you divide by 1.5 on both sides, you are going to have this. Okay, now question 9.5, how will the reading on the voltmeter V1, okay, V1 is connected across the battery, how will the reading on the voltmeter V1 be affected if the 5 ohms resistor was removed? Choose from increases, decreases, or stays the same. 1 mark. Okay, if the 5 ohms resistor was removed. Okay, if this is removed. Okay, if you remove this. Now, can you see when the switch is closed? Okay, when switch S is closed, okay, you are going to have 10 plus 2, 12 ohms. Okay, you are going to have a series connection, 10 plus 2, 12 ohms. So can you see the external resistance is going to increase from 5.33 to 12 ohms. Okay, you are removing a branch so that you have a series connection. So from 5.33 to 12 ohms, okay, a series connection. Now, how will the reading on voltmeter V1 be affected? Remember, the voltage is calculated as follow: current times resistance, and V1 is going to read the supplied voltage. This depends largely on the external resistance. Okay, so when the external resistance increases, the external voltage will also increase, okay, because the external voltage depends largely on the external resistance. You can see from 5.33 to 12 ohms, okay, 12 ohms. So you're going to have increases. Now question 9.6, explain your answer to question 9.5. Okay, 9.6, explain your answer to question 9.5. Okay, so you have to explain this way. Total resistance increases while the current decreases. Okay, you can see 12 ohms. Total resistance increases. The current will always do the opposite of the resistance. Okay, when resistance increases, the current will always do the opposite. Okay, when resistance increases, the current will decrease, always the opposite of the resistance. Okay, this is what I have. Okay, total resistance increases, okay, 12 ohms, right, from 5.33 to 12 ohms. Okay, total resistance increases while the current decreases. Okay, and you also have to mention the external voltage. The external voltage, okay, V1, the supplied voltage to the external circuit. The external voltage will also increase, okay, because the external voltage depends largely on the external resistance. Okay, so as a result, the external voltage increases while the internal voltage decreases. The internal voltage will always do the opposite of the external voltage. Okay, so when the external voltage increases, the internal voltage will decrease. And you also have to mention about the EMF and internal resistance. So the EMF and internal resistance will always stay constant. Okay, so this is how you can answer this question. Remember to mention resistance and current, and then external voltage and internal voltage, and then EMF and internal resistance. Okay, so we are done with this practice question part 1.